I'm wondering what you think some of the main gatekeeping definitions of cognition
Yeah.
are, and then how yours sort of builds upon that to promote research.
Yeah. Um, it's fine to have terms for specific things that you're interested in. So if you study advanced human level metacognition, it's okay to have a word for what it is that you do, for the same reason that, I often argue with people when they say, well, this is a neuron. I say, well, what's a neuron exactly, right? Most cells do what neurons do, just, more slowly. But, when you're studying neuroanatomy 101, that's not the time to have a debate about what neurons are. Everybody in the class should know what they mean, and that's okay. But more fundamentally, it is essential to understand that these terms do not have useful, sharp delimiters. And there's two ways that you can sort of convince yourself that that's true. On the one hand, all you need to do is try to trace it back to the time that you were a single cell. You can do that either during development or during evolution, but inevitably, if you believe you have some sort of cognitive property, just ask yourself, well, where do you think that peters out? And usually, oftentimes people will say, well, when the brain shows up, well, that's a very long process. And they'll say, okay, fine, when the cortex appears or something, say, yeah, that takes days and weeks. What's happening during that process? When does it sort of wink into existence? And there is no sharp story to tell about any of this. Likewise, with brains, science fiction dealt with this, many decades, probably well over 100 years ago. And there's a cool story by Terry Bison, I think, called "They're Made of Meat." And it's two aliens that suddenly realize that one of them is telling the other one that I found out what these humans are made of. They're made of meat, and the other one's like that can't. There's no way. That's just ridiculous. There's no way you can get cognition out of meat. That's nonsense. And you can just imagine uh, our preference for this particular embodiment. What are you going to do if and when we discover life elsewhere and it's made of completely different principles? Are you really going to say that just because they don't have a brain architecture like ours, that's not real cognition? That seems ridiculous to me. And I think we really need to understand what is fundamental about the terms that we use, and our smooth and continuous history with the abiotic world tells us that these things have to scale gradually. Yes, of course, there can be some phase transitions and so on, but all of this scales gradually. The other and maybe more in the end, kind of more forceful argument is simply this: what are the consequences of this kind of gatekeeping? So I'll give you a simple example. Gene regulatory networks. Gene regulatory networks are a computational model of genes interacting with each other, and so it's a collection of, let's say, 10 nodes. Each one is a gene, and then you draw little arrows, and they turn each other on and off, and you've got this model, and these things control development and physiology and health and disease and a million other things. So you look at this thing, and if you're into cognitive gatekeeping, you would say, okay, look, this is a deterministic, very simple system. I can see all the interactions. It's a mechanism. It's a machine. There's nothing here that you could use to say that that has cognition. That has now having said that, having done no experiments to show that, by the way, just having this opinion, which often people do, what that does is prevent you from making further discoveries. The discoveries that you might make, as we did a couple of years ago, is to say, well, actually, what if we don't know what the cognitive properties of this thing are? We don't really know where on the spectrum of cognition it fits. Let's find out. Let's do an experiment. And what you can do is you can say, okay, what if I try some tools from behavioral science? What if I try training it? If you try training it by stimulating the various nodes and to see what happens to the other nodes, you find out that it actually has 6 different kinds of memory, including Pavlovian conditioning. And so it turns out you can train it. Who knows what else? We haven't finished that investigation. For all I know, it may do lots of other interesting sort of proto-cognitive things. But the point is that once you've discovered that, now all kinds of interesting therapeutic modalities become possible, because it means that the way to change what it does is not just the traditional rewiring, which is if you think it's a machine and it's not on the spectrum of cognition, then your only options for changing its behavior are you add nodes, you remove nodes, you change the links between the nodes, right? So gene therapy and promoter modification and things like that. So the hardware. But it turns out that that if you're willing to do the experiment, you find out that actually no, they have these. They're trainable. They can be trained, which means that trains of specific kinds of stimuli will get the network to permanently change its behavior. That's memory, right? Changing future behavior on the basis of past experience. And it turns out that you don't actually need to change the hardware in order to change its behavior, because like many computational systems, it learns from experience. And so that offers all kinds of new potential therapeutic roadmaps, where the way you're going to control all of these pathways is by stimulating them with in some fashion that you derive using the tools of behavioral science. So there, it's very simple. If you make assumptions because you want to gatekeep this terminology, you are closed out of certain discoveries and certain new approaches to standing problems. And if you're willing to take these things as empirical matters, then you would do an experiment and you would find out which of the tools of cognitive science are actually appropriate. And then you have new opportunities for research. And so that's what I think the bottom line for all of this is. If somebody has an opinion about the terminology use or about certain systems, my question is always the same. That's great. What has that framework let you discover? And then we find out, whether we like that opinion or not.
I'd like to go back to something you said a little bit earlier, which was that sentience isn't a term that you use so much as it is something that your co-author Nicholas Rouleau likes to use. And I think that asking why you don't use it will lead to something interesting maybe. And my hunch is that, so you said you laid out these 4 categories ranging from the simple machines to the systems that learn from reasons. And you said that other than persuadability, I mean, one thing that where something is on the hierarchy tells you is to what extent you need to be concerned with the way the system is modeling its environment. And something that I've gotten from talking with people like Dennett or Michael Graziano at Princeton is, or Joseph Ledoux at NYU, is that the more advanced a system is, the more it models. And as things get toward this 4th level on the hierarchy, they might begin self-modeling. So that's something where maybe language is very important, or communicating with others. We have to be aware of what we're thinking, what we're revealing, what we're not revealing. And I'm wondering if this is where you think sentience would fit in, self-modeling, and if you're not as interested in this because the focus of your research is more on agents lower in this hierarchy, like slime molds or anthrobots or xenobots or things that aren't self-modeling.
Well, I would say this. I think that looking for self-modeling as a property of brainy animals is way too late. So I think cells self-model, and I think that Chris Fields and Carl Friston have very sophisticated views of aspects of physics where you can look at that capacity even in very kind of minimal physical systems that we wouldn't even call alive. So I think just by itself making a model of yourself is not that hard. It certainly doesn't require being a mammal or having a complex brain or anything like that. We can easily put together a kind of a thermostat that, in addition to measuring the room temperature, also has a metacognitive loop where it measures its own state. In fact, bacteria measure
Okay.
their own metabolism to have an idea of how things going for me nowadays. Now what you do have in advanced creatures is a special kind of metacognition where they know that they know, right? And that's yet a more complex thing. But I think sentience, in the way that Nick defines it, which I think is perfectly good, which is he calls it the capacity for subjective experience. If you take as subjective experience, and again, I'm not specifically getting into the kind of the swamp lands of talking about consciousness per se, because I think that's a whole other issue. But in terms of functionally, in terms of looking at a system that has a unique subjective experience, in the sense that it has a different perspective on the world than you as a third person observer do. It has its own memories, its own perspective on the world. It has its own valence about things, and so on. I think that happens very early on, and I'm not avoiding the term. It's just I think that I think you already get that by the time that you're talking about systems that have a perspective that you need to grapple with, and that can be a very asking. I mean, look, Randy Beer